Okay, guys, so here's part two of the video of ionization and bonding. So if you guys take a look here, this is the notes that we went over on Monday. There's a video of this too, and but this is basically what we ended up figuring out. We figured out that certain atoms will ionize either to become positively charged or negatively charged, depending on their valence electron shell, right? Is it going to be easier to pick up, or is it going to be easier to drop off electrons? For some, it's easier to pick up. For others, it's easier to drop off. And usually that magic number is 4, right? If you have 4 valence electrons on your outermost shell, you can do either. You can either pick up or drop off. If you have more than 4 valence electrons, then you're gonna pick up. And if you have less than 4 valence electrons, you're gonna drop off. So that's just a good rule of thumb to remember when doing when thinking about this, okay? So what's going to happen now, right, is we're going to talk a little bit about bonding. Okay? Now, we said yesterday or the day before that when things pick up or drop off electrons, they form these new things called ions, right? You have an ion here, you have an ion here, you're either an anion or a cation. So what happens though in this quest to become more like noble gases, right? Because remember, this is the goal, to get that full valence shell. What happens though is you kind of create another imbalance, right? Before we talked that atoms naturally exist with 0 charge because they have exactly the same amount of protons that they have as electrons, yes? But because now they've picked up or dropped off electrons, now we've kind of thrown things a little bit out of balance and we end up with these charges, right? We end up with the +2, we end up with the -1. So even though now they have a full shell, right, we've created another imbalance. Now we have an imbalance where we have magnesium, right, instead of being a nice neutral atom, right, it's happier because it has a full valence shell. Now we're getting into the position where now we have magnesium and fluorine coming forth as ions, right? As ions. So what this does, right, is it creates that imbalance because even though now they have a full shell, well, now they're carrying around a charge and they don't want that, right? The goal of everything is to be in perfect balance. So by balancing one thing, we're kind of throwing something else out of balance. So what happens is that these ions now look for one another to kind of balance out those charges. Now, one of the things we have to remember is that when we're talking about ionic compounds, is that balances, in order for them to balance, charges must be opposite, right? They must be opposite. Opposite charges attract and similar charges repel. So if you have something that is negative and positive, right? These guys are going to come together. They're going to come together because they're going to attract, right? Similar, opposite charges will attract each other. If you have 2 negative charges, for example, okay, negative charges are not going to attract one another. They're going to repel, right? So they're going to push away from one another. And the same thing happens with 2 positives. If you have 2 positive charges, right, they're going to do exactly the same thing. They're going to push each other away. And the best way to remember this is to think about it kind of like a magnet. You ever get 2 magnets together and then they stick together and then you flip them around and they kind of push each other away? Well, this is exactly the same principle, right? We call this electrostatic attraction, okay? Electrostatic attraction, basically saying that opposite charges will attract each other. We have a cation of magnesium and we have a cation of fluorine, right? So, an anion of fluorine, excuse me. So because these guys are opposite, what they're going to do is they're going to come together, right? They're going to come together, they're going to attract one another, and they're going to try and balance out these charges, right? They want to get back to 0, okay? So how do we do that? How do we get these charges to come back to 0 and be neutral? Well, here's a trick, okay? Here's a trick. All right, we're going to use these charges, and we're going to use these charges to make a compound. And here's how you do it. Here's how you do it. Okay, I'm going to get this out of the way. If you take this compound, this number, and you bring it down here to become the subscript, and you take this number and you bring it down here to become the subscript here, okay, you form this compound, magnesium. You don't have to write the 1, but we'll write it here. And then fluoride. You see how the numbers just kind of switch places? Okay. Since the 1 is understood, we don't need to write that. So the compound will look like this: magnesium and fluorine. And this is a chemical compound. You've taken the charges of 2 ions and you've brought them together to form a compound, okay? A compound has a few parts, okay? Let's talk about the number first. This is called a subscript, okay? And this subscript will tell you how many of that particular element, okay, you have in the compound. And this represents the chemical symbol, okay? The chemical symbol. Chemical symbol. The chemical symbol, okay, is going to tell you what elements are involved in the compound, right? So in this case, we have 2 elements. The first element is magnesium. And the second element is fluorine. So we know that this compound is made up of magnesium and fluorine. Now, for the magnesium, in terms of the amounts, that means that we have 1 atom of magnesium and 2 atoms of fluorine, right? And we get that by those numbers, those subscripts, okay? Okay, now, what are we doing when we're switching these charges? Well, look, this is the math behind it, okay? If I have a magnesium, right, and that is a 2+, and I have a fluorine, which is a 1-, right? If I take those charges, 2 minus 1, do I end up at 0? No, I end up at +1. So this is not 0. So because it's not 0, right, it's not balanced. You need to make sure that those charges cancel each other out, right? You want to make sure that when you do this process here, right, your answer should be at 0. So what we need to do then, right, is we need to make sure that we have enough negatives to cancel out that positive. So what we're going to do is we're going to multiply it by 2. We're going to multiply it by 2. So what that does then is it gives me a magnesium, which is a 2+. And now 2 times 1, that's going to give me -2. Therefore, if I take 2 minus 2, because this is the fluorine here now, right? 2 minus 2, well, now I'm at 0. This is the goal, right? This is the goal. The goal is to balance the charges to make sure we end up at 0. So in order for me to balance these charges, I'm going to need 1 magnesium, right? And 2 fluorines. And that 2 is represented here in the subscript, right here in the subscript. Okay? So this is why compounds happen. We create an imbalance to balance out the valence shell, right? Then, since we're walking around with a charge, we're going to go out and we're going to look for somebody with an opposite charge to try and cancel out what charge I carry to get back to neutral. So compounds form to neutralize ions. To neutralize ions. Okay, this is why these things happen, right? Everything has to come back to balance. Okay, everything has to come back to balance. So let me give you an example and we'll start from the beginning. Okay, give you an example and we'll start from the beginning. Let's take a look at something like calcium. Calcium. Okay, calcium, if I do the valence, the Lewis dot structure has 2 valence electrons. All right, and let's take a look at something like phosphorus. Phosphorus has 5 valence electrons. Right? Okay. So let's see what ions these guys form. Okay. Looking at calcium, it has less than 4. So I already know that it's going to be easier to get rid of these guys. They're going to get donated. Right? So when those guys leave, right, calcium then is going to form calcium. Hang on, let me get rid of that here. Calcium 2+. Okay? Because phosphorus has more than 4, right? It's going to be easier for him to pick up. So he's going to pick up those extra electrons that he's missing. In this case, he's going to pick up 3 more, right? So because he picked up those 3 more, right, phosphorus is going to form the ion 3-, right? So now I have calcium 2+ and phosphorus 3-. So let's take a look what happens. Let's form the compound. Okay. Let's see here. Calcium 2+ and phosphorus 3-. And what I'm going to do to form the compound is I'm going to make the switch here. To form a neutral compound called Ca3P2. And all I did was switch those. See, this one came from here, and this one came from here. Okay, and this is your compound. Now, let's double check to see if it's neutral. Well, if calcium has a 2+ charge, and we multiply this guy by 3, and phosphorus has a 3- charge, and we multiply this guy by 2, well, 3 times 2 is 6, and 2 times -3 is -6. If we take 6 minus 6, guess what? We're at 0. We're neutral. Okay, so that's what we're trying to achieve when we're making these compounds. Now we're going to do a little bit more work in class, but I want you guys to get the basic understanding of what bonding is right here, and then we're going to get to the nitty-gritty face-to-face. Okay, all right guys, I wanted to make this video for you guys just real quick. If you have any questions, please let me know.